If we look around the house and see some devices that take some kinds of motions like these ones, there is a chance that they uses DC motor. Just connect a battery to a DC motor and somehow start to rotate. So in this video, I'm going to talk about how a DC motor works. This is a magnet. It has north pole and south pole. If we move another magnet very close to it, two things will surely happen. It's either they attract each other or they repel each other. And this depends on the sides they were facing to each other. Opposite poles attract and the same poles repel each other. So if we arrange two magnets like this in such a way that we have north pole on one side and south pole on the other side, and we move a magnet close to it, opposite poles will attract and same poles will repel each other. If we keep changing the sides of the magnets, the two magnets just keep rotating. In a magnet, there is something called the magnetic domains. The magnetic domains were aligned in a way that they were all facing the same direction. And that is the reason why magnets were capable of attracting metals. The magnetic domains also exist in metals, but they were not facing the same direction, and this makes metal incapable of attracting other metals. But as soon as we make some tons of coil around the metal body like this nail, the magnetic domains will align and start facing the same direction as that of a magnet, and this will make it to act as a magnet. It will be capable to attract other metals and will also have the ability to attract or repel magnets. This is called an electromagnet. Electromagnets are sometimes called temporary magnets because we can turn it on or off, and we can also change the poles of the electromagnets by changing the polarity of the battery. In the case of normal magnets cannot be turned off, and that's why it's sometimes called permanent magnets. If we have two curved magnets facing each other like this one has north poles towards the other and the other has south poles towards the first one, and we have an electromagnet in between the two magnets. As soon as we connect a DC supply such as battery, the electromagnet will try to spin due to the two magnets that were beside it. As I've said earlier, opposite poles will attract each other and same poles will repel. As soon as the electromagnet spin a bit, it will stop because the south pole has reached the side of the north pole and the north pole has reached the side of the south pole. This is a commutator ring. The ends of the electromagnet were connected to the commutator ring. The work of the is to change the poles of an electromagnet, and this makes a DC motor to continue its motion. So for my motor to continue its motion and have a very high speed, I decided to make many windings. In both sides of the commutator ring, I placed two conductors, which were also known as brushes, because they switch contacts around the commutator ring. The brushes were to switch the poles of the electromagnets. South pole becomes north pole and North Poles becomes South Poles. If we connect an alternating current to this DC motor, it won't work. I hope you've gained an understanding about DC motor. So do like this video, subscribe and click on the notification button. Thank you.